Assalamu alaikum my dear students, hope you are well by the grace of Almighty Allah. Welcome to an IVS homeschool. This is Muhammad Emdadul, Assistant Teacher of Mathematics, National Ideal English Version School, Day Shift. Dear students, today I am going to conduct a higher math class of class 9. Our today's topic is Chapter 1, Part 5, Laws of Sets. Dear students, in this part we will learn some law of set. Okay dear students, let us see our today's learning objectives. Commutative law, associative law, distributive law. It means that in today's class these three law will learn. Okay dear students, so at first we have to know what is commutative law for sets. For any set A, B, C. At first we are learning commutative law. For any set sets A, B, A and B. For any set A and B. First one is A union B is equal to B union A. Second one, A intersection B is equal to B intersection A. These two laws are known as commutative law. Commutative law of set. For any set A and B, A union B is equal to B union A. A intersection B is equal to B intersection A. These two laws are known as commutative law for sets. Dear students, how can we prove this? I will show you. What do I mean by these two sets? If we replace the change, if we interchange the position of the set, then this will remain same. This law is known as commutative law. Okay, so we will prove this one here and you will practice this one at home. So I will solve one solution. This commutative law I will solve in this class. Okay, so at first we have to consider any element in A union B. So let X is contained in A union B. To solve this, we have to know two things here. At first, in case of element, when it will be union, we can write this as OR. If it is intersection, we have to write here AND. Why we have to write OR and why we have to write AND? OR means the element contained in the first set or in the second set, that will be contained in their union. If it is intersection, that means the element will have to contain in both sets. For this, in case of intersection, we have to write AND, and in case of union, we have to write OR. So we can write X is contained in A union B. What does it mean? It means that X is contained in A or X is contained in B. So we can write here, that implies this sign means that implies that, or you can say issue from, it means that we are getting from the previous line. Okay, X is contained in A or, as here is union, I am told to write or. X is contained in B. Now, as X is contained in A or X is contained in B, then we can write interchanging this, X is contained in B or X is contained in A. So, this implies X is contained in B union A. What does it mean? It means that I have taken X is any element of A union B, but I have shown that X is also an element of B union A. What does it mean? It means that A union B is a subset of B union A, as every element of A union B is contained in B union A. So, we can write here A union B is a subset of B union A. Conversely, if we can show that B union is also a subset of A union B, then we can say A union B is equal to B union A. Depending on this logic, we have to prove. Okay, so we can consider an element in the right side now. So, we can write here again. You will write below, I am not writing below. Again let X is contained in B union A. That implies X is contained in B, or as this is union, we have to write X is contained in A. So, we can write X is contained in A or X is contained in B, both are same. So, we can write here X is contained in A union B. Therefore, we can write here B union A is a subset of A union B. What does it mean? I have shown here I have shown A union B is a subset of B union A, and here I have shown B union A is a subset of A union B. It means that both the sets are equal. So, we can write here therefore A union B is equal to B union A. This proves the first law of commutative law of set, first law of commutative law of set. So, you will practice in this way second law for commutative law. Okay, second commutative law for set A and B. Okay, dear students, I hope you have understood this one. So, commutative law is done. Now, I will solve associative law. Dear students, so at first we have to know associative law. For any set A, B and C, A, B and C, we know two laws. Associative law. For any sets A, B and C. First one, we know A union B union C. A union B union C is equal to A union B union C. And second one, we know A intersection B intersection C is equal to A intersection B intersection C. These two laws are known as associative law. These two laws are known as associative law. Depending on previous system or according to the previous system, we will solve this associative law. I will solve first one and second one is given for your homework here, this one. So, I will solve one here, solution. So at first consider any element in A union B union C. Okay, so let X is contained in A union B union C. That implies X is contained in A union B or X is contained in C. That implies we can write here X is contained in A or X is contained in B. Now here is or X is contained in C. This part I have written here, and from this part I have written this. Okay, now we can write here X is contained in A or X is contained in B or X is contained in C. Now we will consider this B with C. Now X is contained in A or X is contained in B union, as here is or, we can write here union C. Now we have to remove this or, so we can say X is contained in A. For this or we can use union sign. X is contained in B union C. X is contained in A union B union C. What does it mean? It means that A union B union C is a subset of A union B union C. So we can write here, therefore A union B union C is a subset of A union B union C. Now conversely, if we consider an element in A union B union C, and then we will get that element in A union B union C. So let us show that. Let X is contained in A union B union C. It means that X is contained in A or X is contained in B union C. What does it mean? It means that X is contained in A or X is contained in B or X is contained in C. Now we have to consider A with B. So we can write here X is contained in A or X is contained in B. Now here or this part X is contained in C. So now we can write X is contained in, removing this or, we can write A union B or X is contained in C. Now we can remove this or by using union. X is contained in A union B union C. What does it mean? It means that A union B union C is a subset of A union B union C. Therefore we can write X, therefore we can write A union B union C. A union B union C is a subset of A union B union C. From this one and this one, from this and this, we can show that A union B union C is equal to A union B union C. Okay, dear students, I hope you have understood the associative law. I have solved first one, second one is given for your homework. You will do this as your homework. Okay. Now I will go to distributive law. What is distributive law? Distributive law. Distributive law for set. For any set A, B and C, we can write A union B intersection C. A union B intersection C is equal to A union B intersection A union C. And second one we can write here A intersection B union C is equal to A intersection B union A intersection C. Okay, dear students, now these two laws are distributive law for sets. First one is given for your homework. Here see, first one is given for your homework. You will solve following the second one. I will solve here in this class second one. Okay, so I will solve two distributive law, second distributive law. Solution. So we can solve in the similar process. Let X is contained in A intersection B union C. B union C. What does it mean? It means that X is contained in A, X is contained in A and X is, as here is intersection, we have to write and. X is contained in B union C. Now we can write X is contained in A and X is contained in B. As here is union, we have to write OR. X is contained in C. So now we can consider B, A with B and A with C. So we can write here now X is contained in A and X is contained in B. As here is OR, write OR. Again we can write X is contained in A and X is contained in C. So now we can write here X is contained in A intersection B. X is contained in A intersection B. As here is OR, write OR. Again X is contained in A intersection C. So we can write here, that implies X is contained in A intersection B. As here is OR, we can write union A intersection C. What does it mean? It means that A intersection B union C is a subset of A intersection B union A intersection C. So we can write here, therefore A intersection B union C is a subset of A intersection B union A intersection C. In similar process, we can show the next part. Again let X is contained in A intersection B union A intersection B union A intersection C. That implies X is contained in A intersection B or X is contained in A intersection C. What does it mean? It means that X is contained in A intersection A and X is contained in B. From this we can write X is contained in, here we can write or, X is contained in A and X is contained in C. So now we can take X is contained in A common from both. So we can take X is contained in A and X is contained in B, or this, or we have to write X is contained in C. So we can write here now X is contained in A and X is contained in B union C. So we can write X is contained in A intersection B union C. Okay, dear students, I hope you have understood it. What does it mean? It means that every elements of A intersection B union A intersection C is contained in A intersection B union C. So A intersection B union A intersection C is a subset of A intersection B union C. So we can write here A intersection B union A intersection C is a subset of A intersection B union C. Dear students, from these two we can say that left hand side is a subset of right hand side, and conversely right hand side is a subset of left hand side. It means that these two sides are equal. So we can write therefore A intersection B union C is equal to A intersection B union A intersection C. I have proved the second law for distributive law. Okay, dear students, now you can remember a technique in this case, in case of commutative law, in case of associative law, in case of distributive law. To prove these three laws, you can apply a technique. If you can solve the first part, second part just you have to write conversely. At first write the last line, then write the previous line of last line. In this way, if you write conversely, you will get the second part. Okay, dear students, so do your homework following our today's lecture. Homework 2 is given and 2 questions here. First one is associative law and second one is from distributive law. Submit this homework on next Saturday. Keep practicing at home, abide by your parents, stay home, stay safe, see you again. Till then, Assalamu alaikum.